Hello everyone, thank you for being here. Hope you enjoyed the Kotlin Conf. This is the last slot. We are Friday. I imagine you're a bit tired, but let's keep a bit of energy together. I have one question to know you a bit better. Just raise your hands if you are using Koin in the audience. Quite a few of you. Cool to see all these people using Koin here. Just a quick presentation of myself. I'm Arnaud Giuliani. I've created Koin in 2017, and the project is still going well. And today, we will talk about how we improve the experience of development with Koin. Koin is a dependency injection framework. That means that it helps you structure your application. And the idea is that Koin provides you an easy way to be super efficient with all of that. And we talk about improving the developer experience with Koin. And of course, the talk is about the Koin 3.2 version, but time is flying. And then there's already out there Koin 3.3, 3.4. We talk about a few things about there. Then hope you will enjoy. Let's step back. And I try to explain you Koin in 2 minutes, more or less. And what's about dependency injection? Dependency injection is about having a few classes, and then you want to wire them, and then having access to them in the instance. And let's have a simple case here, for example, class A, class B. And the idea of Koin is that it's used the Kotlin language to provide a DSL. Then we open module here, that is a section. It provides you a space to help you configure your application. And then we have another keyword, single here. And then here we are describing a singleton into our application. The thing here is that behind this single expression is directly Kotlin. It's your code, it's something that is compiled directly in your code. And then here you may see that we are instantiating directly the class A. And then if we are making the same for class B, then we try to declare things, and then we need something to wire the instance needed by class B here. And this is the game of dependency injection, understanding where to find the things for you. And the third keyword you need to know, at least to begin to use Koin, is get. If it's go, And then in this function, then class B with get, we say to Koin, yes, give me an instance of class B, and go on your side, look at something that is looking at this type in your pocket, and then give me the dependency. And then we are gone. This is how we create all the instances with constructors. We can then also use complex Kotlin function. You can write whatever you want inside those configurations, and then it works. The thing is also this DSL can allow you to have a few parameters, a few options, and then here we can say to Koin, can you create this instance at your start? And then when we run a program, then a Kotlin program with main function, we just say main, and then we just use the start Koin function with modules, and then we say that we are starting off modules, the previously module function that we have used as we can set as a value. And then it's creating instances. Okay, pretty simple. Dependency injection has to be simple. In the case where the class that you want to instantiate is not cannot be created by Koin, you need to use field injection. And to use field injection, in our case, for example, this class myApp, you can't be created directly by Koin. Then you need something. You need something to inject your class B instance from Koin, and then this is what we have, is a Koin component interface that help you unlock the Kotlin extensions from Koin, and then give you the power to use inject function anywhere it goes. And then this is how we have this inject function to inject a field inside my app. And then you see we have if you instantiate my app, then you will have access to class B from a Koin container. You may have found this kind of inject function in Android application. And the good thing of Kotlin is that we can make extension directly out of the box in any kind of system. And you feel like it's part of the main SDK that you are playing with. Like here, we are using app compat activity. It's an Android activity component. And we are using inject, and we are not using the Koin component interface. And then, how we can do that is that Koin provide out of the box all the extensions for you to have the Koin features available in Android. And that's it. But sometimes, the DSL can become to be really verbose. And then it tends to, you could have some real expression like that. And you could be, yeah, something like that. Well, this is a good time then to have lots. We had lots of feedback from people that say, hey, Koin is great, but really having dozens of gates per line is really annoying. Then the good question, how we can avoid to have those gates everywhere? Because finally, the thing inside Koin is that we are not making any introspection. We are not making any reflection on your code. Then we are just executing your code inside the DSL. Then, okay, we have this. We have our configuration. How, from this single definition, then we have two singletons, two kind of component, but we have gets. We have to say to Koin, hey, give me the dependency, please. And in this, what you have is that you are writing your function, but we are giving you the tools. We are giving you the API. Gate is the Koin API to let you write the dependency. To go forward, what we have currently, and if you want to look at the source code of code, this is something that is looking like that. Then the first idea of the DSL was to say, we give you keywords, and then you can manage to use those keywords and functions to write your injection. But now we are looking to the other point. And then we say, OK, give me your functions, and I will put all the injection inside. And then we are more close to the inversion of control of the dependency injection thing. And then it feels more natural for this kind of dependency injection framework. But you can use both. Like, you can write functions, and if you want, we can inject all your components if you want. How it goes then? You see, I've written single function with a function, and then the new keyword that we have released in Koin 3.2 is single off. That means that we are creating a single, and then we are taking a pointer to the class constructor directly, and then it's working, it's creating the instance for you. The idea is that it's easy to write, to read, easy like the DSL. We keep consistency in the semantic. We have the same keyword for you. And also, in terms of changes, it won't break anymore. Like if you change something in one of the constructors you have defined here the configuration, it won't break. Like if you were using the classical DSL from Koin, you would have a change in the constructor, then your compiler would say, hey, there's something that's moved here, you need to edit your code. And then this is how, finally, we have something that is more fun to use, and then accessible in terms of also capacity for KMP. Great. The good news is that it works with dependency, but then it can work with more advanced features like injected parameters. The idea of injected parameters is that if we have a class and we want to pass a data at the time where we are creating the instance, we keep the keyword here, single off, and the class directly. Don't forget the semicolon. Warning about current IntelliJ stuff behavior is that sometimes the import don't work. Like if you try to type directly double semicolon and my class A, IntelliJ don't find your class, then you have to remove the double semicolon and then import the file and then put the double semicolon. Something I really need to check with the IntelliJ team, but you may have something in terms of import to check. But then we have this class. We need a data, which is an ID. We define it in Koin. And then what we do is that we pass this parameter to Koin to say, this is the ID I would like to create the instance with. And then you see that here, the writings are simple. Then I don't have to care about writing about my injecting parameters. All of this is great. It will cover, let's say, 80% of your usage, but in some case, you will have some difficulty and you have problem to use that because Kotlin can offer you default values, name parameters, and then you will require to go back to the classical DSL because when we take your function, we take all the parameters and we try to put get on it on every parameters. As this is the same, we don't make any introspection, any analysis, then we won't be able to understand, are you using default value? Are you using anything else in terms of value for this constructor parameter? The thing is, if you have complex expression, keep using the classical DSL. If you have a definition that is quite long and using only get, you can use directly this new constructor DSL format. This experience also helps us to go forward for the other options that we have for the DSL of Koin. And what kind of options would we have on this DSL is we need a qualifier. Qualifier is a label you put on a definition to try to differentiate two kind of definition of the same type. If you want to put extra binding, if you want to create things at start, then we may have lots of options appearing in terms of DSL and construction. And the thing is, in the classic DSL, then we have parameters. Then you see that we are opening parentheses, and then we say named. It's the way to indicate we are using qualifier. We can say we are creating this instance at start. Then it's another parameter. And also, if we want to bind a compatible type directly for this definition, and says, for example, this definition don't bind only my class, but my class and my component types, then I need to add it. But you see that finally here, in terms of experience, we are mixing operators, parameters, then can be a bit weird in terms of handling those functions, handling all those APIs, then yeah, this is not super great. This is good, but not great because then for us also, it blocks us from providing new extensions and new way to work with your DSL. But then we have a new constructor DSL. We can take this chance to open a new options DSL. And then you have these functions. We are creating an instance for my class A, and yeah, we have the place here to directly open something, a block code to let you write anything you want for this definition. And then we could use the function named qualifier, create it at start, and then bind any kind of components you want. Yeah, this is great, and this is more readable compared to the other way of writing your definition. It's interesting. And you can use this way to write options with the old format of definition. Okay, then we have a class, and the compatibility is done with an operator named with_options. And you use with_options, and you will unlock all the new DSL options for you directly. And then you will have the same kind of approach of describing options for all your definitions. It's a good way for us. It's super important to keep it readable, to keep it simple, to have things that you don't have to really be scared about how you write things. We talk about the DSL improvements, and now we will talk about how we handle module dependency in Koin. Then in Koin, you handle module. This is space where you are describing all your components. Here, for example, we are describing two modules, one for UI module and a data module. And usually what we do is that we say we are starting Koin with those modules directly. We say modules and UI module and data module. OK, fine. You can use directly a list of modules, and you can use operator with the plus operator. Then, okay, that's fine. You are using a list of modules. But we are getting into some limitations. And for you, it's a bit strong because there is no strong link between modules, like you are using UI module and data modules. There is no link, and you are making the link dynamically by loading everything. And in terms of scaling, you could break things without understanding in terms of dependency from what you are using in terms of other modules. Then it's a good thing for us to give you the possibility to clearly express some includes. Even it feels a bit like, yeah, it should be already there. It's a natural options. The Koin community didn't really require such options. And really with big companies that are using Koin at scale, it's really become really important to have a mechanism to ensure that we can link everything for you. The idea of includes is that finally, you will be able to reuse many modules from anywhere, and then for us on our side, we are taking all your module graph, all your includes, and then we are flattening everything, and then we are optimizing things. And then it's super important, because then you reduce your configuration complexity, and it allows you to better reuse all your stuff everywhere, and you don't have to care about how you are re-including, how you are reusing such or such definition in other configuration. And then it became super natural to scale in terms of modules, to have one feature module that are using common data, common UI, and then you can scale at many levels. And for you in terms of impact, there will no impact. Even more, we will optimize the way how we are loading everything for you. Then feel free to use directly these includes functions. All of this is directly available as a multi-platform API. That means that this is not restricted to JVM or API. You can use it on the shared code, your Kotlin shared code, or your native shared code, clearly. To unlock all of the superpower, just use the latest Koin version. You have Koin Core. Koin Core is the project for the agnostic Koin dependency injection framework. That means that you can use it for multi-platform and in the basic Kotlin application. After that, you have several flavors of Koin, where we are integrating more feature and advanced feature for Koin in Android and other kind of ecosystem like Ktor. You can use Koin with Ktor directly. But then we are currently in 3.4.0. This is the new version for this semester. And then we will follow up for the patch and the library updates for Android, for Kotlin, and everything around. One new thing we try to launch, and we have launched last year, is proposing complementary new options to write the Koin. If you don't want to use the DSL, you could use annotations. And for a long time, Koin has been a framework really oriented by the DSL. But the idea, if we begin to orient ourselves for annotations, is we don't want to reproduce any existing solution. Like the start of Koin was to say, we can provide tools, fun tools, to let you write things super quickly in a Kotlin DSL. And then you don't have any override in terms of compilation and any other things. But then, if we bring annotation, we really want to bring something new. We really want to embrace this experience of annotating to your code and then going fast, but we don't want to impact your compilation time. And we don't want to give you other impact after that. And yeah, as I said, we have limitation in the Kotlin, in the Koin DSL, because we can't analyze what you are writing. And this is not the right place. And then this is where we are introducing Kotlin compiler plugin. And the Kotlin compiler plugin is the space where we can really begin to analyze your code, to make, even if we want a rewrite code on the fly. But let's keep simple things. the idea will be to, for us, it's a good way to introduce new tools for the annotations. And we are then stepping up with Google KSP that provide us some good tools to avoid to go deeper into the complexity of Kotlin compiler development. I don't know if you've seen Kotlin compiler development talks. It's really, really heavy, and then it demands lots of resources in terms of time to invest. Then for us, the idea is that we will be able to configure everything with annotation. We can go quickly. We want to keep the Koin semantic, the words, the keywords. We want to find them again as an annotation. And then the idea is that we will generate just a few lines of DSL, the few lines that you don't have to write or we would avoid you to write. Then with just an annotation, we will write the single definition for you in a DSL. To set up such projects, you can go on setup.insertcoin.io, and then you can use the KSP Gradle the KSP plugin and use the Koin Annotation Gradle dependency. Let's go into details and begin with annotation, and then let's go back to our simple class, to simple example here. And then if we add annotation and we keep semantic, then we have add single on it to have our singleton. And that's it. We know that it's running, we know, and Koin will start and then know that those dependencies are existing, and then we are running. And no introspection on your code, nothing at runtime to impact you. We can detect type binding, and you can also specify it. Like, for example, if we have another type, and you would like, for example, if you have multiple type, went too fast. If you add an interface here, you do have nothing to change. The definition will bind directly my type also, then class B and then my type. And you see that in terms of parameters, we don't have to specify anything. We know that your constructor will need something from Koin, and then we try to inject things. If you have too much types, then you can specify if you really want to optimize your binding and then expose your configuration for one type. You can go for binds parameter that allow you to make the things, but you don't need. It's really if you really want to optimize your stuff. And then, in terms of dependency, you have nothing to declare here. We understand that your constructor have this type, this type, this type, and then we understand that we are generating the DSL for you. But then we can go deeper. We can understand that this is a new label. And then for Koin, we know it will generate the get or null function for you, access, and then you will have something in your label here. You can write lazy if you want a lazy class here, the lazy type from Kotlin, then it will be detected also. And last kind of type we can detect in the constructor is list. If you want to request all the definition of the given type, here the list of all the class A, for example, then Koin will understand and then generate the get all functions behind in the DSL. And then you see there is nothing for you to write. We keep things really simple. We detect what you have in terms of constructor, and then you can really enjoy to have nothing more to do. You can play with properties and injected parameters. That means that this is special parameters here, and then we need to indicate that this is not a classic dependency here you want to get, okay? Then, if it's an injected parameter, then you tag your property add injected param. And if you want this to be found in the Koin properties registry, then you can say add property on your field. And you see that finally, all of this is really straightforward to use. It's really just for the dynamic properties that you have to type things. Else, we can detect everything for you. Okay, let's recap a bit. let's take just a quick example that is more familiar to what you are using a bit every day. Like we have a repository of data, okay, with an interface, then we target single. Then if you have a presenter, let's say, then we are using the interface directly, then we can say add factory. Factory is a kind of instance in Koin to say it's creating a new instance each time, and single, it's a singleton, then we keep your instance in memory. And then, for example, if we have a view model, it's an Android view model here, then we have dedicated tag for the Android ecosystem. Then the main one is at Koin view model to declare your view model inside Koin as a view model. And then in a few definitions, you cover all your dependency injection. It generates your Koin DSL configuration behind, and then you will have all the automatic injection and binding. Keep in mind that there is the new label detected and the lazy and all the list of type, then we handle for you directly. You don't have to make a special annotation or something. And for properties, then either it's an injected parameter, either it's properties from the system, and then use the proper annotation. But in terms of experience, it's super important for us to be sure that you have the minimal to write, and then you can do the maximum. And it doesn't change your code. You still use the by inject or by view model fill injection in your Android activity or any kind of place where you are using fill injection. It's still compatible. Nothing to change for you. It just changed the way you are declaring things. And then you need modules. Let's see here we have declared the definitions, and here we need a few modules, but we can't use directly the DSL modules. Why? Because then the annotation processing know about classes, functions, but not directly values directly declared like that. And we are in boundaries between runtime behavior and then analytics behavior, then we can't. Simple response is we can't. Then we need module class. A classic module class you may find in other solution is, yeah, I have a class, my module, and then you tag it at module. Okay, super simple. Then the idea for Koin, instead of having a class path scanning or other kind of scanning, is to say, Koin scan this entire package, and then you will have all the definition bound to this module. And then you can have several modules, just bind the package name and then scan for this, and then all your definition will be tied in your module directly. You can, of course, use the includes function that we have seen just before, and then you can include other module class, very classic. But finally here, it's important, as I was saying, we are optimizing all the imports for you. And then inside the module class, you can define also a function. Then it depends how you want to use those annotations. This way to declare things is more close to the DSL, and then the feedback of developers is, yeah, but then better to use DSL, up to you, like how you feel with that. And then you can declare from function, you can declare directly a component, that means that you declare functions, the parameter will be your dependency, and then inside the body of your function, you are using the dependencies that Koin provides you. And lastly, if you want, you can even use top-level definition. That means that you don't have to own modules or to have a modules to write a function to declare definition. And this is one of the latest updates from Koin Annotation 1.2, is that directly from a function in a file, you just tag it with @single, and then you create a definition for you. Pretty straightforward. Then we need to start Koin. You see before that we are using the start Koin keyword, but then now we have DSL and classes. How it goes? Then we still use start Koin function, then the modules, and then The idea is, okay, we need to run a module from the class that you have defined. And the magic here, if we call it the magic, is that the only point of generation, of code generation, is done here, is that we are generating an extension of your on your module class that are representing that is the Koin configuration DSL. We are writing the DSL for you. Then you write less, you use annotation, the flow can be seen as a bit better for you, but then you can use directly the generated code inside your start Koin function. And then up to you to mix annotations or module if you want. Like you can begin to work with annotation if you want to test with annotations. Like you see that this modules function, the myDSL module, is a DSL module, and then the myModule class, you see that we are instantiating the class module. Then we are launching both the DSL, and then we are reaching the generated DSL function. And then up to you to find the way you want to work. Like in terms of impact, it's really super, super fast. The idea is not to reproduce something that is taking long time. And the idea of Koin at the beginning was to say, okay, let's get rid of everything to be super minimalistic in terms of compilation, and then we just need to compile Kotlin. With KSP and just the fact that we are targeting Koin DSL generation, then we have a really low impact. It's super interesting. You can debug it. Like we are generating this DSL, you can just breakpoint inside. If there's something wrong, you can directly go inside and you will understand what has been generated. And then it's not annotation to replace Koin DSL, it's a new tool. A tool to let you really have the way to run, you want to use Koin. Like if you like annotations, then you can use annotations. If you really like DSL, you can continue to use DSL. And you can try to use both. Up to you in terms of team culture to see how you want to deal with that. Like in some team, sorry, you may want to have only one way to write. Then it's available tools. Sorry. Koin is a tool that has always been made to make everything simple. Then my main word, if you have to keep something in mind from this talk, is keep everything simple, please. And something to let you meditate also on. This quote, equal less bugs. Let's talk about what's next with Koin. I don't know if many people have seen, but we have many tutorials to let you use. Sorry, I need a bit of water. To use to begin to use Koin in a many configuration. And then you have Kotlin annotation, many kind of Android application from view model, Jetpack Compose, annotations, but also multi-platform and Ktor. Then you can use, you just check out, you follow, it's a tutorial. In a few minutes, you can run an application that is using Koin. In terms of roadmap, where are we going in 2023? The new version 3.4 is out there, and is already ready to go for you. End of track, that means that in terms of community support, we won't publish any more patch on the 3.3 because it's already 6 months, it's already has been published 6 months away, then we can't hold all the versions. Then in terms of community support, then the new version is 2.4. Latest stable 3.3, and the new stable is 3.4. Then in this release, now the rhythm that we try to address is that we try to keep release from 1 semester to avoid having too much releases. And the problem is that we have Android version, we have Ktor version, we have update in Kotlin, we have update in multi-platform. Then, and now on Compose, then now we have multiple ecosystems to chase, and we try to have a peaceful way to deliver for you new versions. Koin 3.4 comes with the new experimental coroutines engine, and then we are taking new functions to help you make dependency injection with coroutines. And then one of the first features we want to bring also as experimental is that we won't bring any more. You can unblock completely your start process in your Android application. This is really interesting. You can unlock your start process with Koin by loading in the background with coroutines all your modules. You will see on our blog, I will give you the URL later, where you can find the details about the changelog, but here's the new version. And also two new important versions, Koin Annotations 1.2 that is bringing the top level functions, and Koin Worker. And also, the new thing is for us is that we are covering completely JetBrains Compose, then the Compose multi-platform side, not only Android Jetpack Compose, but also all the multi-platform stuff. Then it's super interesting. That means that we extend all the APIs from Jetpack Compose, the Android Jetpack Compose, to the multi-platform APIs, and then we're offering more features like remember inject, remember modules, or remember scope, then something that are more tied to all the Compose lifecycle. Something that is a core value. Koin is a pure open source project and is a community driven. Then just for me to thank you thank all the people that are contributing to Koin, and perhaps some of you are in this wall of faces from GitHub, but it's a matter of people, a matter of making things better together. And this since a few years now, since 2017, we have made a good road. And then if you want to join the community to have resources for news, like you have the website inside koin.io, the Twitter also inside Koin.io, Mastodon we need to see, but yes, we are still on Twitter. And also the Kotlin Slack, the Kotlin language Slack instance, we have a channel -Koin where you can ask questions. If you see things, you can ask questions about all the community. And if you have a real issue, you can also raise an issue on the GitHub project. Koin is an open source project, but with the time, I created a company to help people, to help other companies use Koin at scale. Then we are here to help. And also, we are beginning to launch a new platform, a new developer platform around architecture development, around architecture technologies. Then stay tuned. Go on Kotzilla.io to have the news and to see about also the Twitter. I believe it will be interesting. Also LinkedIn. And if you want stickers, there is my friend Michael that is on the side here. Jump on in to catch some stickers. And thank you very much. And please rate the talk. Thank you. We have a bit of time for questions if you want.
Thanks for the talk. So if I understand correctly, the dependency resolution happens at the compile time, right?
At the runtime.
At runtime. Okay, then I have no question now.
Okay, thank you.
Hello, might be a follow-up to his question, but if I would use annotations, would there be any performance impact at runtime?
No. No. Because then we are just generating a bit of Kotlin code, and then you compile it, and then there is no impact in terms of runtime.
Okay, thank you.
Thank you for the talk. I see you showed two ways to create, with single and with factory, But what if I have like SDK and I have a WebSocket inside it, and this WebSocket instance should be per SDK client instance. So I can have like 2 SDKs and I need 2 WebSockets.
If I understand your question, if you have separated SDK and to see if separated SDK can see the same configuration?
Well, so my SDK have like 2 internal components, and each of them needs WebSocket. But each instance of SDK should have its own instance of WebSocket.
Then you can, this is what we call context isolation. That means you can embed your own Koin context, and then it's completely isolated, and then you have your own instance for your SDK. And then if you have you have your instance on your side, and it's completely separated.
Okay, so it's context isolation exists. Thank you.
Thank you.
Hi, thanks for the talk. My question was similar to the one that was just asked. So if you had an interface and with 2 implementations, and both of those are marked as single, is there a way to somehow at runtime determine which one to use based on some environment variable or something like that?
Yeah. Forgot to mention that we have @named. That @named is a qualifier, and then you give a name, and it takes a string, and then you type @single, and then you have another annotation @named, and then on each implementation you give the right name, and when you need to inject the right implementation, you use @name on the function on the constructor parameter.
Okay, thanks.
Okay, I can take other questions just after that if you want in private. Thank you very much.